hand, as we know. So let us start it. Our lecture today is the reaction of amine. Reaction of amine. So as we told you before that, amine is big family, important family in organic chemistry. So it is so important to know just at least the main information about this family, the amines groups. Okay. So he said here, the chemistry of amine is dominated by the lone pair electron on the nitrogen. This is the important for the amines compound. What we have here, we have n-shape of electron on the nitrogen. So the chemistry and the chemistry properties for this compound is coming from this n-shape of electron on the nitrogen. Only 3 elements in the second row in the periodic table that have the non-bonded electron pair. Okay, any elements is the nitrogen and the oxygen and the fluorine. He talked just about the first row in the periodic table. Okay, so because the basicity and nucleophilicity decrease across to the row, across from the left to the right, okay, the nitrogen is the most basic and most nucleophilic in this element. So if you compare this here, the nitrogen has n-shape of electron, yes, with, for example, with the fluorine. Okay, okay. Anyone has high electronegativity atom, a fluorine. What meaning the electronegativity atom is the ability of the atom to attend, okay, to attract the electron. That meaning how many this atom love the n-shape of electron, okay, to attract the n-shape of electron. So this high electronegativity atom, this low electronegativity atom, okay, anyone is easier to give the n-shape of electron. What do you think? Nitrogen. That meaning this is easier to attack the proton, to attack any atom that are electron deficient. Okay, that meaning this is more basic than fluorine. Okay, we said more basic than fluorine. Okay, the fluorine is more stable, low basicity. Okay, so amines are stronger bases and nucleophile. Look, if we say this n-shape of electron here is easier to do it, okay, to give the n-shape of electron easier than the fluorine, that meaning is stronger base and what? Stronger nucleophile. Okay, it will be stronger nucleophile. Bases and nucleophile than other neutral organic compounds. So if you compare this, look, the reaction as base, this is the n-shape of electron. He will, if you talk about the amines as bases, I told you before that, what is the difference between base and nucleophile? The base attack what? Attack diamond, proton. And the nucleophile attack another elements that are electron deficient, not a proton. Okay? Like carbons, like any elements. Okay? This is the difference between the base and the nucleophile. Base attack a proton. Attack proton, give a proton. Okay? Diamond, the acid, give a proton to the base. But when you said nucleophile, no, the nucleophile attack another atom, not a proton, that are electron deficient. He said here, an electrophilic site. شو معنى an electrophilic site? You write here, partially positive, partially positive. Like what? Like what? Like alkyl halide. This is the alkyl halide. Alkyl halide. For example, this is partially what? Positive, and this partially negative. That means the nucleophile can be attack this atoms, the carbon atoms, as electrophile. Here, as electrophile. You understand? So, amines react as bases with what? With compounds that contain acidic proton. Okay, when you say amine, they are bases, that means the reaction will be must take a proton from the acid. Okay, take a proton from the acid. Amines react as nucleophile with compounds that contain electrophilic carbon. Like what? Like any compound? Like this compound, like aryl halide. Alkyl halide, sorry, not the aryl halide, the alkyl halide. Okay? So this is the difference between the amines, how it will be work as acid, the amines it will be work as bases. Do you understand? Do you understand the difference? Okay. So, what we have in this slide, amines as bases. Yalla. It will be the amine as bases. Amines react as bases with variety of organic and inorganic acid. Okay, like what? Like HA, H like HCl, HBr, H2SO4, المهم acid. Okay, acid. That meaning the unshaped electron, look, the unshaped electron attack the proton, and the bond between the proton and the neighboring atom, it will be what? Break down to the atom to give you the conjugated base. That meaning base give you conjugated what? Acid. And the acid give you conjugated base. This is acid-base reaction. This is acid-base reaction. What acid can be used to protonate an amine? Okay, what acid that used to protonate an amine? Okay, usually acid that has pKa less than 11 or 10. Okay, less than 11 or 10. This is about the pKa. Do you know when the pKa is high, that meaning it will be what? Weak acid. When the pKa is low, it will be strong acid. Okay, so equilibrium favor the products of an acid-base reaction when the weaker acid and base are formed. Okay, so if you look to here, this what? Amine. This is primary amine. And this HCl, acid. It will be react. Unshaped electron take a proton, that meaning it will be convert to the ammonium salt and Cl minus. So look to the pKa here. What is the pKa here? -7. And the pKa here? 10. That meaning anyone is more stable. The 10 or -7. Anyone is the favor to the reaction. If you have this reaction as equilibrium, that meaning the reaction will be go from the left to the right. Okay? From the left to the right. That meaning to the products, equilibrium, it will be favor to the products. Because we have higher pKa value. Okay, more stable. This more stable than this. Do you know the HCl is stronger acid? Yeah, it will be highly reactive. For this reason, the equilibrium is favored to this side. To this side. Okay, look to this. Here, the amines. This is tertiary amine. Okay, has unshaped electron. Take a proton from the acetic acid. This is the acetic acid. How many the pKa? 4.8. Okay, give you ammonium salt. How many the pKa? 11. Okay, also the equilibrium, it is favor to this side. Okay, to this side. Because on this side we has higher pKa value, more stable compound. Okay, salt. You understand? Okay, that meaning many acids can be used to what? To deprotonate and protonate, to give the proton to the amine. Okay, many acids can be used to protonate the NH2 group and amine compound. Do you understand? Okay. So, relative basicity of amine and other compound. Now we compare the basicity of the amine with the other compound. Okay, with the other compound. So the relative acidity of different compound can be compared by using what? By using pKa value. Also, if I don't give you the pKa value, you will know. Okay, without the pKa value. So the relative basicity of different compounds, such as amine, can be compared by using pKa. Also, as I told you, without pKa, also you have ability to know anyone is the more best. Okay, I will give you the rules here. So the weaker, دائما طلبة, this is the important. The weaker the conjugated acid is the higher pKa value. Okay, is the higher pKa value. And stronger what? Stronger bases. Okay, look to this. This base, okay, this base, amine, okay, is stronger base. Acid-base reaction, take a proton, give you this conjugated acid. Okay, look, the weaker the acid is the higher pKa value. Okay, that meaning this has what? Has higher pKa value. Okay, now, if I told you anyone is stronger base, this compound or this compound, what do you think? What do you think? This compound or this compound? Anyone is stronger base? Anyone is stronger base? Left? Okay, why the left?
Because we have at least one pair.
Yes, at least we have here unshaped electron. Okay, but here we don't have unshaped electron. How it will be work as base? Also, I give you the condition of the base before that. The base must have an unshapeable electron, or negatively charged, or what? Or what? Another thing? Yes, double bond. The double bond. The double bond also, some compound that has double bond also can be worked as bases. Okay. Look, I don't give you the pKa value, but you know this is stronger bases than this. Okay. This is the base, and this is what? Conjugated acid. Aslan conjugated acid has able to give a proton, not to take a proton. Okay. So this is the acid. Now, if you compare here, to compare the basicity of two compounds, keep in mind the following. Okay. Any factor, this is so important here. Okay. Any factor that increase the electron density on the nitrogen atom increase what? Increase an amine basicity. Okay. So any factor, with me, step by step. Okay. Look, it's so easy. You have nitrogen atom, yes? You have unshapeable electron, okay? This is the unshapeable electron. What meaning unshapeable electron? Meaning electron density. You have electron density here. This is the meaning of unshapeable electron. Electron density. So, any factor, that meaning any factor increase the electron density. Okay, he said any factor increase the electron density. Any factor, that meaning for example, X. Any group donating, okay? Any factor donating طبعا by resonance effect, by inductive effect. This is the meaning for the factor, okay? Any factor, any group increase the electron density on the nitrogen, that meaning it will be increase the basicity. Here the electron density, it will be more than normal amines, and it will be easy to attack a proton, easier to attack another atoms, electron deficient, okay? So this is the meaning. The reverse, he said, any factor that decrease the electron density. بالعكس, if you have here atoms or group, this group is withdrawing group, that means the electron density here, it will be what? It will be less than other amines, and it will be what? It will be what? It will be decrease the basicity. It will be decrease the basicity. بالعكس, okay? This reverse to this, okay? This reverse to this. So, again, any factor, any group that increased, look, donating the electron density on the nitrogen, that meaning the electron density, it will be higher. It will be bigger than normal amines, okay? It will be increased, it will be stronger what? Stronger base. Okay? The reverse, any groups or any factor that will be decrease the electron density, that meaning withdrawing, okay? Decrease, look, decrease the electron density, small electron density on the nitrogen, that will be weaker bases. Okay? It will be weaker bases. And this, and this. So, comparing an amine and the ammonia. I will now compare the amine with the ammonia. By simple way, Look, the ammonia has a 3 hydrogen atom, okay? A 3 hydrogen atom. The amine at least has 1 alkyl group, yes? At least 1 alkyl group. Now, what is the difference between hydrogen and the alkyl group? Yes, diamond alkyl group is what? Is donating. Okay? If you don't have substituent here, if you have chlor and brom on the alkyl group, that meaning it will be reversed, it will be withdrawing. Okay, be careful. Be careful here. Just if you have alkyl, just alkyl without another atoms, not carbons, okay, just it will be donating group. By any effect? Yes, by inductive effect. That meaning anyone, it will be stronger base. This or this, anyone has high electron density, this or this. طبعا, this is higher electron density, this is here small electron density. That meaning it will be stronger bases. Also, it will be stronger what? Nucleophile. Not just bases. Bases and nucleophile. Okay? So, Look, he compared the two compounds, this and this. The weaker base diamond give you lower pKa, stronger acid. Okay? This stronger base give you higher pKa, weaker acid. Okay? I don't give you this number in your exam. I don't care about this number. Okay? Think about the principle. Okay? Think about the principle. This, it will be his higher electron density on the nitrogen because the affecting of the alkali group, and it will be stronger. It will be stronger bases and stronger nucleophile. Do you understand? Okay. The primary and secondary and tertiary alkyl amine are more basic than ammonia. If you compare primary amine with secondary, tertiary, all of them more basic than NH3. Why? Because the affecting of the alkyl group. Okay? So, he said because the electron donating inductive effect of the alkyl group. The same thing. Effective of the alkyl. Which compound in each pair, look to this homework, which compound in each pair is more basic? This CH3 by 2 NH or NH3? طبعا CH3 by 2 NH because the affecting of the alkyl. Okay, B, CH3, CH2, NH2 or Cl, this is what I about, Cl, CH2, CH2, NH2. Anyone is the higher basic? Yes, the first one. Why? Because the Cl here is withdrawing group. Okay, this the Cl is withdrawing group, decrease the electron density on the nitrogen and make the nitrogen less basic. Okay, be careful here. Be careful here. Do you understand? If I give you here another example. Okay, which compound has higher electron density than the other, or by another word, any compound is more basic than the other? This Cl, CH2, NH2, or a fluor, CH2, NH2. Anyone is more basic? This. Why? Because the fluor here is stronger withdrawing group than the chlor, and so decrease the electron density on the nitrogen, or more decrease the electron and the nitrogen than chlor. Okay? So this, it will be what? It will be stronger base. Okay? So another example. Another example. This or this. Anyone is stronger base? This or this? Left. Anyone is less basic? Right. Why? Because we have here two withdrawing group. Okay? It will be decrease the electron density on the nitrogen. Here he has just one withdrawing group. It will be decrease the electron density on the nitrogen. For this reason, here it will be stronger base. Okay? It will be stronger base. Do you understand? Okay. Do you have a question? No question? No question until here, Talaba? Okay. Comparing the alkyl amine and aryl amine. Okay. Look to the alkyl amine. This is the alkyl amine. Alkyl amine. Any alkyl. Any like this. CH3, CH2, CH3, NH2. For example, this. And what? And this is the aryl amine. NH2. So, now this group exactly different from this group. This aryl group, aromatic, and this aliphatic group is completely different. Okay. Now, if I want to compare the electron density between this NH2 and this the NH2, what we have to think? We have to think about the effective of the different group. This group, alkyl group, is donating group, yes? Donating group. We have just one inductive effect. Now, this is here conjugated with the NH2. That meaning we have resonance structure. Okay. That meaning we have to think about the Anshape of electron on the nitrogen. Are the Anshape of electron on the nitrogen is localized on the nitrogen or delocalized? Okay. If your of the Anshape of electron on the nitrogen localized on the NH2, that meaning it will be stronger than the Anshape of electron that are delocalized over benzene ring, over aromatic part. Okay. So this here localized on the nitrogen, that meaning this Anshape of electron available all the time to attack any proton, to attack any atom electron deficient. But here, the Anshape of electron they are delocalized. They are not available on the nitrogen to attack a proton, to attack another atoms that are electron deficient. This is the difference. Okay. Directly, you have to go to think about the localization of the Anshape of electron. Are the Anshape of electron is localized on the nitrogen or delocalized on the nitrogen? This is the difference. This is the main difference between this compound. Okay. So if you have this Anshape of electron, look, this Anshape of electron, it will be make pi bond here, and this is the pi bond for the benzene ring. It will be open to give you carb anion. This the carb anion is stable or not stable? Stable. Are there is additional resonance structure? Yes. This make double bond, and this it will be open. Give you here negative charge. Where is the negative charge? In ortho position. And meta, we don't have negative charge on meta position. Okay. That meaning ortho, para, ortho again. Okay. This is important note when you write the resonance structure in your exam. Okay. You have to keep in your mind diamond the negative charge of carbon ion. It will be at ortho, para, ortho. Don't write for me negative charge on the meta position. It will be wrong. Okay. You have some wrong. So negative here ortho, para, ortho. Look. Ortho, para, ortho. Carbon ion, 3 1, 2, 3 resonance structure. Finally, this it will be make pi bond, and this it will be again to the first structure. That meaning, are the Anshape of electron localized on the nitrogen or delocalized? They are delocalized. Okay, the Anshape of electron is delocalized over benzene ring. For this reason, it will be give low basicity if you compare with the aliphatic amine. So once again the pKa value, I don't care about the pKa value. I don't give you the pKa value on your exam. Okay, just you have to know. Just you have to know. So because the pKa of the NH3CH2, this the ammonium salt, is higher than the pKa of the benzene with the ammonia of the aniline, we said with the aniline. So the CH3, CH2, NH2 is stronger basic than what? Than aniline. Than the aniline. Okay? Diamond this, they are more basic than anilines. Okay? Because what? Because the resonance effect. They make, because the resonance effect, it will be delocalized the Anshape of electron over benzene. Yes, it will be give you stability for the compound. Okay. Now, if we say anyone is more stable, this or this? Yes, this, of course, this is the more stable. For this, more stable, weaker base. More stable, weaker base. Yeah. The same meaning. Okay, aryl amine are less basic than alkyl amine because the electron pair on the nitrogen is what? Is delocalized. Delocalized, خلاص. Do you have a question? Do you understand? Okay. Substituted aniline are more or less basic than aniline. If anyone asks you, you have aniline here. This is the aniline, yes? Now, I give you substituted aniline. Substituted aniline. NH2, and we have here a group. For example, here, a group. I will tell you anyone is more basic. This or this? What's your answer? Yeah. Yes, depend on this group. Are this group donating or withdrawing? If you say donating, it will be different. Yes. If you say donating, to be increase the electron density on the nitrogen, and it will be give you more basicity. Okay, if you say this, it will be withdrawing, it will be decrease the electron density, and it will be give you less basicity. Okay, depend on this group, depend on this group. So any group is donating, as you take it before that, last year, this NH2, they are donating. Okay, by any effect, if you remember, by resonance effect, inductive effect, do you have it or not? NH2? Yes, they has inductive effect, but the stronger one is the resonance effect. Okay, they has inductive effect. Okay, the same thing. OH, the same thing by resonance effect. OR by resonance effect. NH, COR by resonance effect. Why all of them by resonance effect? Why? Because we have a lone pair on the atoms. Because we have lone pair on the atoms. Okay, the R group is donating by an effect, by inductive effect. Okay, so give me examples about withdrawing group. This all the halogen, they are withdrawing group. Okay, by any effect, their resonance high and not for the halogen. Yes, also the hydrogen has resonance effect and the inductive effect, but the stronger one is what? Is the inductive effect for the halogen. For this reason, the halogen, they are family alone. Okay, family alone for deactivate and activate the benzene ring. So C aldehyde group, ketone or aldehyde, esters, carboxylic acid, cyanide, sulfonide, nitrine. Okay, this the ammonium salts. All of them, they are withdrawing group and decrease the electron density on the nitrogen and less basic than aniline. Okay, they are clear. This all, both of them, so clear for you. So, do you have a problem here? Do you have not? Do you have a question? Do you have a question? Do you understand? So, if we have homework, next slide. Okay. Rank the following compounds in order increase what? Increase basicity. Yani from the less basic to the more basic. Okay, this aniline and this aniline substituted by withdrawing group, NO2. Okay, that meaning NO2 group withdrawing, it will be more than aniline or less than aniline? Basicity, less than aniline. So, here we have CH3. CH3 donating by inductive effect. That meaning this compound has more basic than alanine or less basic than alanine? More than. That meaning you have to rank. Anyone it will be number 1. This it will be number 1. Anyone it will be number 2. This it will be number 2. Anyone it will be number 3. This 1, 2, 3. Okay, 1, 2, 3. 1, 2, 3. Okay, it will be like that. So look here. He show you how the electron density, how the anisotropy electron here, it will be resonance and it will be withdrawn by NO by resonance effect for the NO2 group. Okay, it will be conjugated and also the negative charge, it will be go to the NO2 group. Okay, so is here, yes. How many resonance structure we have here? If I say to you, right or possible resonance structure, how many resonance structure? Yes, it will be how much? Yes, 3 for benzene ring and 2 for the nitrogen. It will be 5 resonance structure. Okay, try on your home to draw all the resonance structure. Do you have a problem? No? Okay. Rank the compounds in each group in order and increase basicity. Yalla, and increase basicity, yani from the less basic to the more basic. Aniline and this, what do you think? More than basic, more than aniline or less than aniline? Basicity. Methoxy is donating, that meaning more basic than aniline. This group is ester group but withdrawing group. Okay, this withdrawing group, that meaning is less basic than the aniline. That means it will be number 1 and 2 and 3. Okay, so this rank this compound. Here we have alkali group. Now, it is not benzene ring. Here we have alkali group. Alkali group is donating by what? By inductive effect. Here we have aniline. Okay, anyone is more basic than the other? Alkyl, yes. It is this cyclohexylamine. Okay, so this is the adenine. That meaning this is more basic than this. Okay, come to this to compare this. Nitro group is withdrawing. That meaning is more basic than adenine or less basic than the adenine? Okay, anyone it will be number 1. This number 1 is the least basic compound. And number 2, this number 2. And number 3, this it will be number 3. Okay? Do you understand? Do you have a problem with this question? So, comparing an alkyl amine and what? Now, we compare the alkyl amine with what? With the amide. The same thing if you talk about the amide. Look, to compare the basicity of alkyl amine and the amide, we must once again testing the localization of the anchovy electron. Are the anchovy electron, they are delocalized or localized over nitrogen, okay, on the nitrogen atom. Okay, so with aliphatic amine, the electron pairs is what? Again, is localized on the nitrogen atom. There is no resonance, okay, in aliphatic amine, like this aliphatic amine, okay. But in the amide, in this amide, here we have here 2 resonance structure. This the anchovy electron make double bond, this pi bond here, double bond, and this pi bond it will be open to the oxygen and give you the second resonance structure. That meaning the anchovy electron is delocalized or localized on the nitrogen atom? Delocalized. Okay. Anyone is the more basic? This is the amide compound or the amine, normal amine? Or for example this the NH2. If you compare the amide with this compound, anyone is stronger base? Of course, the amine is stronger base than, for example, than amide, than this. Okay, this is the stronger basic. Okay, why? Because the resonance effect here with the carbonyl group. We have resonance with the carbonyl group. Okay, anchovy electron on the nitrogen is delocalized over 2 atoms, nitrogen and oxygen. Amides are much less basic than amines because the electron pair on the nitrogen is what? Is delocalized. Is delocalized. Of course, طلبة دائما in your exam, if I told you anyone is more basic than other, explain for me. When you explain, write the sentence, also the resonance structure, okay? When you say is over delocalized, where is the delocalized? Show me how it will be delocalized, okay? You have to write the resonance structure all the times. Tamam? Okay. In fact, here he said, amides are not much more basic than any carbonyl compounds. Okay, any carbonyl compounds. When amide is treated with acid, this is the amide, it will be treated with acid. Look, we have here the amide and the meaning here. This is the amide. When I treat this compound, react this compound with, for example, with HCl. With HCl. Okay. Where is the anchovy electron? Where is the anchovy electron here? Oxygen, we have 2 anchovy electrons. Here on the nitrogen, we have 1 oxygen anchovy electron. Okay. So anyone is better to react with the proton, to take the proton. This number 1, or this the anchovy electron on the nitrogen, it will be number 2. What do you think? Anyone is, it will be better to protonate it than NH2 or the oxygen for the carbonyl group? Okay. Anyone? Okay, look. Test it. Test it. If the anchovy electron take a proton from the acid, okay, for the amide, the oxygen atom, give you this compound, this intermediate. Are this intermediate, the positive charge on the oxygen, oxonium ion, are stable or not stable? طبعا, if there is resonance structure, it will be stable. If there is no resonance structure, it will be not stable. Okay, that means this pi bond it will be open to the oxygen, and the positive charge it will be give you carbocation. Carbocation. Okay, that meaning we have 2 resonance structure. This the anchovy electron, it will be make pi bond, and the positive it will be go to the nitrogen. That meaning we have 1, 2, 3 resonance structure. That meaning when the proton go to the oxygen atom. We have three resonance structure. Okay. Test it now. The unshuffled electron take a proton. When the proton go to the nitrogen, okay, it will give you this resonance structure, this intermediate product. Sorry, are this intermediate product has resonance structure or not? Think. Do you have resonance structure here for the positive charge? No. Why there is no? If we say this unshuffled electron, this it will be open. It will be positive near from the positive. Yes, and two positive charge near from each other is not stable. Okay, they are not stable. So there is no resonance structure here. There is no resonance structure here. Okay, anyone is more stable with three resonance structure or without resonance structure? Yes, more resonance structure. For this reason, if you have amide and it will be react with the acid, diamond, the proton go to the oxygen atom. It will be protonation for the oxygen atom, not for the NH2. Okay, not for the NH2. So writing the following compound in order increase basicity. Yalla, increase what? Basicity. Okay, now this or this or this. Anyone has less basic than other? Think. You have to think. Okay. Aniline, compare the aniline with this compound, with the cyclohexylamine. Okay. Anyone is more basic, cyclohexylamine or aniline? Okay, cyclohexylamine. More basic than aniline. This is finished. Okay, come to this. This the amide or the aniline? Amide or the aniline? Aniline. Aniline. Yes, the amide is less basic than aniline. For this reason, rank the following compound in order to increase basicity. It will be this. It will be number 1, and this it will be number 2, and this it will be number 3. Okay. Tamam. Okay. Amines as nucleophile. Do you have thing? Okay. Amines as nucleophile. Amines react as nucleophile with what? With electrophilic carbons atom. Okay? With electrophilic, look, with electrophilic carbon atoms. That meaning now it will be work as nucleophile, not as basic. Okay? Not as basic. Give me examples, if you remember, for the nucleophilic substitution compound. Yes, this is number 1. Also, if you have alkyl halide, this is the alkyl halide, for example. See, we have hydrogen here, hydrogen, CH3Br, and we have here, for example, any amine, for example, CH3. This, okay. Now, this is the unshuffled electron attack this the carbon partially positive, and this it will be leave the structure for this by SN2 mechanism. Here the amine it will be work as what? As nucleophile. It will be attack another atoms. They are electron deficient. Okay, they are electron deficient. So the amines react as nucleophile with electron carbon atoms, with electrophilic carbon atom. This is the electrophilic carbon atom. The details of these reactions have what been described. We take it before that in your SN1, SN2 mechanism, if you remember. Okay, if you remember, amines attack carbonyl group to form a product in nucleophilic addition or substitution. This here talk about the aldehyde and ketone. Okay, the aldehyde and ketone. If you remember the aldehyde and ketone, this aldehyde or ketone, if you put here hydrogen, it will be aldehyde. If you put alkyl group, it will be ketone. So the primary amine attack with the aldehyde and ketone to give you what? To give you carbonyl amine. Carbonyl amine, not a stable compound. It will be lost. It will be removed or lost the H2O molecules to give you what? To give you amine. Okay. From secondary amine, give you what? Give you enamine. Also, this is substitution on the carbonyl. Substitution on the carbonyl. Addition. This is the addition and on the carbonyl. On the carbonyl group. Okay, so where is it here? He said the nature of this product depends on the carbonyl electrophile. This is the carbonyl electrophile. This reaction are limited to what? To primary and secondary amine, not tertiary amine. Do you remember tertiary amine, it will be not react with the carbonyl group. Okay, tertiary, just the primary and secondary. Okay, tertiary cannot be react with the carbonyl group. So it is just limited for what? For the primary and secondary amine, because only this compound has yield a neutral organic product. The product, it will be what? Finally, it will be neutral. Okay, if there is no hydrogen, if you use tertiary amine, there is no hydrogen here, it will be not give you, it will be give you salt. It will be give you salt. Okay, it will be give you salt. So aldehyde and ketone react with the primary amine to form imine. طبعا without mechanism. I don't give you the mechanism again. You take it before that. Okay, with the primary amine and secondary amine to form what? To form enamines. Primary amine give you imine. Secondary amine give you enamines. Okay, is it clear for you? Okay, if you have a question, you can ask me. If you don't have a question, I will go to the next slide. What we have? Reaction of the ammonia and the primary amine and secondary with what? With acid chloride. Also, you take it before that in the carboxylic acid derivative. If you remember the what is carboxylic acid derivative? Like what? If you remember, like anhydride, like acid chloride. Okay, like. Yes, also the amide, they are also from the carboxylic acid derivative. Okay.
So you want to come at level 50 or level 15? What? Decide. I'm done with the other group. 15? When you finish the program?
I think I have just 10 minutes. 10 minutes later.
At the 30, we do not have time. So level 30. Thank you very much.
Okay, okay. So, yes. So here, it will be, I said to you, the carboxylic acid derivative like anhydride, like acid chloride, like amide, like another carboxylic acid aslan. Another compounds, give me another compounds. Esters, do you know the esters? Okay. Also, so acid chloride and anhydride react with the with NH3 primary amine and secondary amine to form primary, secondary, and tertiary amide. So this is the acid chloride, for example, acid chloride or the anhydride, acid chloride or the anhydride compound. React with the ammonia, give you primary amide. React with secondary amine, give you secondary amide. React with with the primary amine, give you secondary amide. React with the secondary amine, give you tertiary amide. Okay. So if you use tertiary amine here, it will be give you quaternary salt, ammonium salt. Okay, it will be give you quaternary ammonium salt. So draw the product formed when each carbonyl group, this compound, okay, it will be react with the following amines. This react with this. What is the product? This react with this. What is the product? Okay. Now this react with both of them. What is the product? This react with both of them. What is the product? Okay, this homework for you. طبعا, of course, this ketone react with the primary amine, give you what? Ketone, not amide. Ketone give you imine. Yes, imine. This is the secondary, give you enamine, and like the others. Okay, here we have different. Here it is not carbonyl group. We have substitution here. All of this, it will be leaving group. Okay, it will be give you amide. Here it will be give you amide. This homework for you. Okay, I don't resolve the homework also. Do you have a question? Do you understand this? Just Z here, just you have to note here. The Z is leaving group. You have to replace the leaving group with the, yes, with the amines. With the amines. Just replace the Z. Z طبعا here it is the chlor or the acid anhydride. Both of them. Can be used this or can be used this. Overall result of this reactions is what? Is substitution of the leaving group, substitution, change. Okay? The leaving group is substitution by nitrogen nucleophile, by the amines. Substitution, nothing else. Okay? Without mechanism, also the mechanism is easy, but without mechanism. Okay? Do you have a question? No question? So, Now, the conversion of amine to amide is useful in the synthesis of the substituted aniline, for the substituted aniline, okay? دائما, when you use an organic synthesis, it is very useful here, okay? For example, here, aniline itself doesn't undergo Friedel-Crafts reaction. This is the aniline. If you go to use AlCl, this, okay. Do you remember, for example, the benzene compound? And this is the benzene compound. It will be react with the, for example, alkyl halide, CH3, Br, Al, Br3. Yes, this, the reaction, it will be alkylation. It will be alkylation, okay? It will be alkylation and give you what here? Give you CH3. Give you CH3. But when you want to use the aniline, here like that, NH2, the aniline, here cannot be, this reaction cannot be happen. CH3 طبعا, Br, Al, Br3, this reaction cannot be happen because the aniline will directly react with the Lewis acid and the reaction, it will be stopped. And this, inshallah, we will talk about it, inshallah, in the next lecture. Okay, I will stop to here. And just I will give you the notes and inshallah continuous all subject next lecture. Okay? Do you have a question? It's just the idea I give you. Inshallah, next lecture we talk about this reaction.